Okay, so I'm just going to make a little quick screencast about this, which is what we used at Kano to make the spell recognition engine for the new wand kit. These are the spells that we're recognizing, and we're also trying to not recognize these, which are not spells. It's quite simple, really. We have a machine learning model that takes in a variation of each of these hundreds of thousands of times and labels those as ASIO, or actually index 0, and then these as index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Oops. And I think there's 26 spells in total, 27 being not a spell, which I also train on but isn't recognized. So I have a touchscreen monitor, so I can draw Wingardium Leviosa, and they get recognized as at 99.99 with its score, or so I can unlock doors, conjure birds, send up red sparks, make a snake. What are the other ones? Oh yeah, change color of something. Flipendo, which is the knockback spell. I'm not quite sure what that does. Knocks people back, I presume. Knocks things back. Yeah. So, as you can see, it tilts them slightly because up and down with the wand, when you press the button, if you don't press it completely flat, you could be slightly varied. So, I vary the shape of the spell shapes. Oh yeah, this casts a fog or something. There you go, recognise that. Yeah. So if I found a shape that, like that, for example, that's coming up as ASIO, but really it's not a spell at all, I can now put that in the not a spell category, and I click on edit, and this runs on JavaScript, the JavaScript version of TensorFlow, and so let's do that a couple of times. Yeah, like it's been recognized as a few things, impedimenta, and so there we go. I've added that to the training set. Now I can retrain. I could train from scratch, which would make it would zero out all the neural network connections and start again, or I could retrain from where I am, which is what I'm going to do. So click on retrain, and hopefully I can give you a little bit of an insight into what's going on. Let's see. So now it's doing the training, and it's got an accuracy still of it's getting what it thinks is most of them right. So here's the source code. So I've made a library called gesture spells, which recognizes the gestures, and this is the training JS, which does the training function. So this is the one we actually use in the kit itself, and this is the training data, the takes the training data and converts it into a model to ship with the data, with the spell, with the wand right here. So let's see. There we go. So this is the actual training loop here, where we get. Here we go. So it's going to loop over the training data, get a batch of training data which is randomly generated on the fly from the training set we give it, which you can feel free to go and tinker around with. And then if it's getting an accuracy of greater than 9.99999, which means it's probably got nothing else to learn from the data that it's got, then it breaks. But I don't want it to do it on 0, so I said that and that. So don't do it. Don't give up on the first try. Then on the save iteration frequency, if that equals 0, because if the iteration and the iteration frequency. Let's see what the iteration numbers are. Here we go. We've got, so every 2,000 sets, so it can go up to a possible 400,000 batches it will try, and you need that when you're going from nothing. Hopefully it won't take that long to do. Then the save iteration, so every 2,000 it will kind of check and say, am I getting a really good score? If I still am getting a good score after 2,000, then that's great. Just break, save the model, save it to so we save it to local storage, and then enable. So that means disabled equals false, means it enables the button so you can press those again. And that's it. It's that simple. Oh yeah, and so once it's saved the model, then it loads it so you can try it out. And then you can download that, which you do by pressing the save button, which is somewhere. It's very simple. It's just that TensorFlow has a save function that allows you to download the model, and I can demonstrate that here. So now it's retrained. I can download the model again. There we go. It gives me two files. The JSON telling me about the typography of the model and the weights for that model, which can then be included in the app. But I'm probably going to add a few more not spells before we actually ship it. So I'm not going to add that to the model. Add that to the app just yet. Okay, that's a quick run through of tensorflow.js and how we used it at Kano to be able to recognize all the spells from Harry Potter that we're going to in our app. And they look a lot nicer in the app. But I'll let you buy the one to find that out. Okay, thanks now. Bye.